With the extraordinary advances of AI that we've seen over the last few years, I think many of us are beginning to wonder what the jobs of the future will look like. Will machines be our doctors, our lawyers, our accountants, our drivers? But surely there's one thing that machines will never be able to do: creativity. After all, isn't our creativity an expression of what it means to be human? A few years ago, I saw something which really shocked me: creativity by a piece of code. This was in the context of a game, the ancient Chinese game of Go. This is played on a 19 by 19 grid, and players put down white and black stones on the grid. And you win the game if you can surround more of your opponent's territory than they have of yours. Traditionally, this game has been one that has been very hard to write code to play at any high level at all. The game involves a lot of creativity, intuition, a certain amount of pattern recognition of the stones as they build up on the board. And Go players find it very hard to articulate why they're making particular moves, which means it's very hard to translate that into code. Code in the past was written in a very top-down manner. You told the machine, if this, then do that, if that, then do this. You really had to understand how you were playing the game in order to be able to write the code. But over the last few years, there's been a real phase change in the way that we've been writing code. Code now is being written in a very bottom-up manner. So the code is allowed to learn. It can change itself, mutate, and become something new through its learning process. So every time it fails to win a game, it understands, what could I have done better in order to win the game the next time I see this particular situation. And so a company in London, DeepMind, decided to use this approach to train a piece of code to try and play the game of Go. They took a lot of human games, and the code learned on those games and then very quickly ran out, and so it started creating its own synthetic games. It started playing different versions of itself and then choosing the version that was winning the game more often. And in this way, DeepMind felt that they were able to produce a piece of code that could challenge the world's best human at this game, who was a Korean player called Sedol. Sedol was totally dismissive of a piece of code that could play at his level, but he was deeply shocked when he lost the match 4-1. And he in fact regards the one game that he did win against AlphaGo as his most valuable of his whole career. I suppose we shouldn't be so surprised at computers playing games at such a high level. After all, Garry Kasparov lost to a computer at the game of chess in the 90s. But for me, the really interesting thing is what happened in the second game of this match. Sedol had played the 36th move and had laid a white stone down on the board, and he was already feeling rather exhausted, so he went to the top of the hotel in Seoul where they were playing for a cigarette break. We humans still need a bit of nicotine in order to stimulate our creative juices. AlphaGo sat there for some time and then asked the human player to place a black stone on the 5th row in from the edge. Interestingly, we still need humans to be able to pick up the stones and place them on the board. I was watching these games obsessively on YouTube, and I remember the gasp of the commentators when this move was made. Because traditionally, early on in the game, competition is for the outer edge of the board, and it's regarded as a very weak move to play 5 rows or deeper into the board. So the commentators at this point were very excited and said, well, Sedol should be able to win the game from this point on. And when Sedol comes back down from the cigarette break that he had and he sees this black stone on the 5th row in from the edge, you can see the shock on his face. But he's a little bit more suspicious. He's already lost the first game, and he thinks for some time about why the computer has made a seemingly such a weak move. The game continues on, and towards the end of the game, there's competition for territory building up from the bottom right-hand corner. And it turns out the person who controls this territory is the one who's played that black stone down on the 37th move very early on in the game. AlphaGo controls that whole piece of territory and wins the game. For me, this is an example of a highly creative move made by a piece of code. There's a useful working definition of what we should mean by creativity made by Margaret Bowden, a cognitive scientist. She said we should regard something as creative if it is new, surprising, and has value. Well, this Move 37 was certainly a new sort of move. It was surprising because all the commentators gasped when it was made, and ultimately it had value because it won AlphaGo the game. So I think that we should regard this as a creative move made by the code. And this is a creative move made by the code and not the humans who coded it. Because if any human had seen that line of code play on the fifth row in from the edge, they probably would have removed it, regarding it as a very weak move. So this line of code appeared because of the learning process of the code and was not programmed in by a human. A human would have deleted the line and regarded it as a weak move. So I think this is a really exciting moment in artificial intelligence. This is a moment when code does something creative, not the coder. And it set me off on a journey to explore, well, where else can code be creative? Could it write a great novel, compose a symphony, or paint a masterpiece? The story of AlphaGo set me off on the journey which culminated in the publication of my book, The Creativity Code, to see where else could code be creative.